Welcome viewers. In today's class, we want to solve problems on kinematics. And here we have an example which says that the position of a particle moving along x-axis is given by x equals to 2t minus 3t squared plus t cubed, where x is in meters and t is in seconds. So A, find the velocity of the particle at t equals to 2 seconds, and B, find the average speed of the particle in the time interval from t equals to 2 seconds and t equals to 4 seconds. But before we proceed to solve this problem, there are things I would like us to note. So the first one is that when we find the derivative of a constant, it gives us 0. So far, here in the particle, we don't have a constant, but let me assume that the first 2t here, maybe let's assume that t wasn't there, it was only 2 or any number, then that number becomes a constant. Are you following what I'm trying to say? So if we are finding the derivative of a constant, at that point it will give us 0. So let me return this back to what it was. That is the first thing I want us to note. And the second one is that if we find the derivative of a particle, the derivative of a particle ax to power n, it will give us anx to power n minus 1. What am I trying to say? This symbol is symbol for derivative, and a here is a constant. It's a number. It's a constant. And also n here is a constant. So if we have a particle such as x, and when we find the derivative of this, it will give us anx to power n minus 1. Another thing I would also like us to consider is that if we find the first derivative of a particle, the first derivative of that particle gives us the velocity of the particle. See what I'm trying to say? F prime x, x prime x, you can write it this way. It depends on the nature of the book you're using, but if you see f prime x, it means the first derivative of a particle. Most times you can as well see something like this. Okay, so if you see something like this, it's still the same thing as the first derivative. So this simply means mathematically rate of change of displacement with time. Of course, this quantity signifies a quantity which is velocity. So the first derivative of a particle, let's say x in this case, gives us the velocity. And if we decide to find the second derivative of another quantity, or this quantity as a second derivative of this quantity, it will give us acceleration. What I'm trying to say in essence is that So what I'm trying to say is that if we find the second derivative of a particle f prime prime x, it could be written as d square x over dt square or dv over dt. That gives us a quantity which is acceleration, the rate of change of velocity with time. So we are going to also apply this in today's class. Okay, so let's go down to the solution proper. Okay, this one says the position of a particle moving along x-axis is given by, we already know this. Let me highlight this. Find the velocity of the particle at t equals to 2 seconds. So the particle is written as x equals to 2t minus 3t squared plus t cubed. To find the derivative of this particle, which is the x over the t, the x over the t, then this will reduce to 2 minus 2 times 3t. So here we have 2 here. And then this 2 minus 1, this will give us 1. So let me assume that there is nothing there. I also come here. The derivative of this will give us 3t to power 2. I have to edit this and put 2. Okay. So the x over the t, which is the first derivative, gives us velocity, is the same as 2 minus 3 times 2t plus 3t squared. Okay, so since we were looking for the velocity of the particle at t equals to 2 seconds, in place of t, we are going to put 2. Okay, so when we do that, the equation will reduce to what we have here. Okay, so 3 times 2 here is 6, and 6 times 2 here is 12. So the whole of this becomes 12. And here we have 2 square is 4. So 4 times 3 is 12. So the whole of this becomes 12. You can as well use your calculator and simplify it. You will see what I'm trying to say. Of course, minus 12 plus 12 will give us 2. So the derivative, the first derivative of that particle, which is the velocity, gives us 2 meters per second. Okay. So the second option says, find the average speed of the particle in the time interval from t equals to 2 seconds and t equals to 4 seconds. Average speed. Can call it average velocity. We are going to use the formula Okay, so to find average speed or average velocity, we have change in x all over change in t. Change in x all over change in t, or we can as well use x2 minus x1 all over t2 minus t1. So in the problem, we already have t1 to be 2 and t2 to be 4 seconds. So it is left for us to find x2 and x1. So we are going to find the x1, which represents the position of the particle. I take the first, the expression again. So let's see what x1 would be. Okay, so let me call this x1. Okay, so you now see, since we had t1 to be 2 seconds, in place of t here, I am going to replace 2. So I come to this side and then replace 2 here. I do the same thing to this one. Okay, so when you simplify this, what you will get at this place, 2 times 2 is 4. Simplify this, 2 squared is 4. 4 times 3 is 12. Is 4. 4 times 3 is 12. Here we have 2 to power 3, which is the same thing as 8. Which is the same thing as 8. So 4 minus 12 here will give us minus 8. Minus 8 plus 8. So T1 becomes 0. So the whole of this will reduce to 0. Okay. Okay, so for us to find x2, we still use the value for the expression for the particle, and we are going to substitute t equals to 4 into that expression. So let me call this x2. Here we have t, so in place of t here I'm going to put 4. In place of t here also I replace 4 here, and then this other one I do the same thing. Okay, so you can now see at this place we have 4 and 2. 4 times 2 here is 8. 4 times 2 is 8. 4 to power 2 is 4 times 4, which is 16. And then 16 times 3 will give us 48. 48. So we replace 48 here. Here we have 4 to power 3. 4 to power 3 will give us 64. Okay, so 8 minus 48 plus 64 would give us 24. You can as well try that with your calculator. 24 meters for displacement. So what do we mean now? The rate of change of displacement, x2 minus x1. x2 minus x1 would give us 24. Can you see what I'm trying to say? x2 here is 24 and x1 is 0. So in this equation, x2 minus x1, we will have 24 up there. So I'm going to edit this and replace 24. And for T2 and T1 would be 4 minus 2, the time that was given in the equation. 4 minus 2, which is 2. So 24 divided by 2 will give us 12. So the velocity becomes 12 meters per second. So that is how far we can go for this very problem. Let's look at the next one.